Happy New Year's 2026. My name's Mark, welcome back to my channel. And as you can see, I'm still trying to troubleshoot and get my milling machine back working again. If you're not interested in the troubleshooting of this mill and find my other random content annoying, jump forward to about 19.5 minutes. I've got time cards below in the video description. Now, I ended 2025 on an absolute high note because I went skiing on New Year's Eve and it was just the best day skiing I've ever had. Blue skies all day, no wind, and the temperature stayed cold enough, -8 Celsius was the high, that the snow was just perfect for the entire day. So I hope you've all also had a very positive end to 2025 and a great start into 2026. Just to quickly recap, what's wrong with the machine? I'm getting following errors. Either when I first try to latch the machine on, it drops the latch straight away, or if I try to jog the Z-axis up and down, it goes into following error immediately as soon as I start a move. And with the Y-axis, I can do a slow jog in or out, but as soon as I stop that jogging motion by taking my finger off the jog button, it also has a following error. And that's what we're trying to troubleshoot today. Do you know what following error is?
I don't.
Well, just imagine I order you to cut 20 slices of leek per minute.
Yeah.
But you only cut 10 slices of leek per minute.
Yeah.
So that's a following error of like 100%, well outside the bounds of what you were ordered.
Yeah, I guess that just tells you that you can't order me to do things.
In Utopia, CNC machines follow orders.
They do?
Yeah.
Wives don't.
Well, in Utopia, maybe they do. And because no system's perfect, we always allow a certain range of acceptable following errors. For example, wife cutting vegetables, the allowable tolerance on cutting vegetable frequency is quite generous.
Good.
But with a CNC machine, it's quite narrow. And the weird thing is I just looked at my old backups, and for my X and Y axis, I was giving it allowable following errors of 0.2 of a millimeter at low speed and 0.5 of a millimeter at high speed. But on my Z axis, I was giving it 1 millimeter at low speed, but 20 millimeters at high speed. And I do not know why I set it up like that back when I set up the system.
Well, it just means that CNC machines, like wives, are not very predictable, are they?
And what's the solution?
You just deal with it.
Now, big thank you to all of you who offered help on my video from last week where I asked for troubleshooting advice. And especially big thank you to Peter, one of my very generous Patreons, who also happens to be an electrical engineer who designs power circuitry and owns a very similar machine. I think his is a copy of a Maho, but also has the Indramat Servo system. So thanks very much, Peter. I really appreciated the tech calls we had together and look forward to chatting again. Now, one of the suggestions made, why am I even trying to use 40-year-old electronics? Why not just rip all that old stuff out, rip out all the old contactors, replace it all with something modern? I did a video when I first converted this machine, and especially at that time, I did not have the knowledge to be able to design an electrical cabinet and get everything like that working. I've now done something similar on the Shoblin, so I don't have quite as much resistance to that idea as I would have had. However, for the most part, I still think most of this hardware is very good, high quality equipment. It's done very little use. I don't see that in itself being the direction I'll go with this machine. However, if you're into that sort of thing, one of my Patreons, Johan, has the YouTube channel Workshop 54, and he's just started exactly that. He's got the same Maho as me. He's ripping out the motors, the drivers, everything, the contactors, the whole works, and he's replacing everything with an EtherCAT system. So I'll leave a link up here. Go and check out what Johan's doing, and I'm sure he's going to have some questions. He might need some help with some of this stuff as well. Now, your suggestions basically fell into 4 major areas. The first one being contactors. there's something sounds wrong with the contactors of this machine, or at least during startup. That's a very good point you've identified. It could be an issue with the adjustment, or also failed components in the 40-year-old Indramat servo drive module as well. The third area was to look at the motor and tachometer brushes. And the fourth area of suggestion was to look at lubrication. Now the next possible issue would be to look at the encoder feedback from the Heidenhain glass scale encoders, which are mounted on all of the 3 axes. And finally, what about the servo tuning? When I initially did the retrofit of this machine to Linux CNC, it was the first time I'd ever done servo tuning, PID tuning, so it's more than possible that I've got suboptimal tuning of the servos, or that I set the allowable following error limits incorrectly. My aim this week is to try and work through in a systematic way and follow up on all the advice you've given me. The first thing I've done is just gone into Linux CNC's initialization file. Linux CNC has 2 different variables for the allowable following error. F error is the allowable following area at high speeds, and min F error is the allowable following area at low speeds. And those values are in millimeters for my machine. And for the Y and the Z axis, I've taken their existing acceptable following error, which was I think 0.2 on one and 0.4 on the other, and increased those out to 10. Now, one of the most common things identified by you guys in the comments section was that I've got an extremely unusual noise, which could be a contactor. And this is what I mean. Listen when I first start, which is activating this button, and then I latch with the second button. And in that period between initiating the first button push and latching, I've got a very strong buzz. Now there are 3 power relays which latch on during that initial startup phase. This one up here is called 7K1, and it's providing the muscle power to the Indramat driver box. And it's actually 2 different voltages. The X and Y each get 90 volts, whereas the Z axis, which has to lift the heavier weight, gets 140 volt power supply. One of the first troubleshooting steps I was given by my mate Peter, just put a screwdriver on the back of that. Does pressing on the contact change that noise? Which it doesn't. That's one possible indicator that contactor is working normally. To take a further look at that contactor, what I'll do is set up a jogging program to automatically jog back and forth, putting the drivers under load. Then I can measure the muscle power voltages going into that driver under load. Okay, I did that measurement under load. The 90 volt rail was steady at 95 volts and the 140 volt rail steady at 147. Now the other contactors involved in that startup phase is 7K2 and 7K3. And these are normally closed contactors which have to open and take some resistors out of connection, which are only used to short circuit the motors when the system goes off. Once again here, there's no indication, at least from a change in sound, that there's anything obviously wrong with their contacts. Now I suspect that I may have caused a problem here. Now this machine only has a brake on the Z-axis. X and Y do not have brakes, but the vertical axis does on its motor. That brake is controlled purely by the Indramat motor driver unit. Now in the original wiring diagram, we can see that the Indramat controlled the brake anytime the 7K2 relay was closed, providing power to it. So there was a direct wire connection from pin 44 here through till terminal 207. When I designed my retrofit, I didn't know squat, and I was convinced that it was a good idea to give Linux CNC access to that Z-axis brake, and added an extra relay in between, which I called 19K2, to give Linux CNC control over the brake. And I think that was a mistake. So the way it's set at the moment is pressing this top button powers up the Indramat servo driver, which thinks it's got control of the brake. Sometime later, I press this latching relay. Only once the latching relay is pressed does the relay I added, 19K1, close the power loop to power the brake on and off. This is a powered off brake, so it defaults on. So what I've effectively done is, however many seconds or parts of a second I hold this button before I latch the system on, the Indramat is probably trying to switch off the brake and also trying to power up the motor. And I think that bad relay sound that we hear during that startup phase is that fight between the motor and the brake. So what I'm going to do now is just add a jumper wire from 207 back to terminal 44 to reinstate the original design intent, whereby the Z-axis brake is controlled solely and directly from the Indramat. I'm now expecting that powering up the Indramat no longer should make that horrible noise, which it doesn't. Alright, the latching behavior is still the same, but you don't get that bad sound during that phase. And the second thing is, you don't hear the brake go off with such a bang as you did before. That's a very good thing. The problem is, because that motor's been fighting its brake at every startup now for 7 or 8 years, it's possible that I've caused damage to the Indramat system because of that fight. Maybe those axes are out of adjustment. Their internal velocity feedback loop has got 2 adjustment screws. Maybe they're out of adjustment. I never touched those. When I first got the machine, I knew nothing about the system, and I figured the probability of screwing something up is way higher than the probability that they are correctly adjusted from production. It's possible that some previous person doing troubleshooting did some adjustments on the Indramats and they are out of adjustment. I don't know. But at this stage, I haven't touched them. Within those driver modules themselves, it could be old, dried out or blown capacitors. Now, I did replace all of the capacitors when I first got this machine. And when I say all capacitors, I didn't realize that there are square block-shaped tantal capacitors. I didn't recognize them as capacitors, I didn't replace them. So it's definitely a possibility that there's a blown tantal capacitor in there. If the other capacitors are only 7 to 8 years old, could be going out already, but who knows. Also tied up with the electrics of the Indramat driver modules, the TCA280 thyristor drivers are a chip that can also get blown if an upstream capacitor takes them down. Now the third area was to look at the motor brushes and also the brushes in the tachometers. Now the x-axis is easy to get to, that's this one, but the y and the z-axis are not so easily accessible. And in discussion with Peter, we decided not to add any further variables at this stage and not start pulling brushes open. So I've left them for now. Now another one of the potential root causes of these following errors I've been having is lack of lubrication. Are the ways starting to become sticky, or do I have a clogged oil distribution nozzle? Do I have a broken oil line? That means that the axis is not getting the lubrication that it needs, and therefore the frictions increase dramatically. Given that the most problematic axis was the Z-axis, the vertical, and I can feel the way oil on this axis, I obviously don't have any issue with a broken lubrication line here or clogging or anything. Maybe too thick lubrication. And this machine's got a discrepancy between the sticker on the machine saying that the correct weigh oil is a 68 weight oil, and the manual which says the correct weigh oil is a 220 weight oil. And because I only use the machine quite irregularly, and there are sometimes quite long periods where it doesn't get used, I chose the stickier 220 weight oil. I felt that this machine is not getting a lot of use, will have probably quite long periods between uses, and the thicker oil sticks onto the surfaces better, helping to prevent corrosion, and also should provide better lubrication at initial startup after a longer period. However, it's cold right now. Here in the basement, we're down to 11 degrees Celsius. It's 511 degrees Rankine for those of you who use other systems. And it could just be that I've got very thick cold oil. Now, I think I covered the Heidenhain glass scales last time. It is possible that they have oil on the scales preventing them being read properly, or that the light bulb in them is broken or not working properly. But I'm pretty sure we're seeing enough normality in the feedback from them that they're not an issue. What about the PID tuning? Well, I took a look at it with Peter, and one thing we did notice is I've got no integral value set on any of the 3 axes, and I've also got a permanent offset under steady state motion. I tried adding integral to that up to, in fact, about 2/3 of the value of P, of proportional, but I couldn't get any significant change off that or improvement. My understanding when I initially set up the system is you should be able to tune it almost exclusively off follow forward 1 and 2 values, which is the way I did it. If someone has a better input into that, I'm all ears. So now let's just see if I can home. Okay, that in itself is good news. So I can home on all 3 axes. Now let's try jogging. Okay, let's try 1000, 1500. 2,000 millimeters per minute, 2.5. That's max speed. And let's try bringing Z up. No problem whatsoever. While it's pretending to be cooperative, let me just drop out this tool. So I think it's time to put this back against the wall. And with the machine now working again, what was the root cause? Honestly, I'm not sure. There are 4 aspects which I think play into this. It's clear that relay I added to the brake system was causing trouble on startup, but it shouldn't have continued to cause issues once that relay had closed. The second issue is probably lubrication. It's now very cold in here. That thicker 220 weight whey oil which I'm using will have more viscosity, and maybe that's enough drag to cause the following errors such that it would trip existing following error allowance. Were those following error allowances which I set too tight? Is my servo tuning as good as it could be? Servo tuning is one of those difficult tasks. With every iteration you make and you improve things, you then can rescale your oscilloscope, and it all seems like a terrible error again, and then you improve it, then you rescale your oscilloscope. When do you stop? What's good enough? And I really don't know what the correct following error allowance should be in a machine like this. I'd appreciate your feedback from your experience on PID tuning of servos like this. So at this point, I'm not going to start pulling boards out of the Indramat looking for blown capacitors or damaged driver chips. The behavior we're seeing now indicates there's no real issue there. Same for the linear encoders. They seem to be working normally. So I'm hoping now if I set following error limits in winter, then they will also be perfectly fine in the summer months as well. At this stage, it looks like it's working again. So I've just set up to rough out in preparation for a dovetail for a lathe tool holder. I don't think I had my vice quite tight enough, the parallels came a bit loose. Great, we're back in business. That went well. Right, I've got a couple more of these blanks to rough out. The next two are longer. They're a slightly different design. Oh wait, I've just realized that those longer tool holders are thinner than the standard ones, so I needed to reset my Z height. Right, I'm now set up to cut the first dovetail. Now to start with, I'm going to be taking this nice and slow. I'm going to run 300 RPM and a 0.1 millimeter per rev feed rate. Right, well there's my first one done. Pretty happy with the surface finish. This metal does seem to tear out a little bit with those inserts, but the quality of the surface finish on the dovetail looks pretty nice. Much better than the previous attempt at a dovetail cutter. The size is... oh. What on earth have I done there? Why did I write a new toolpath for this when I already cleaned out some existing tool holders and had a nicely dialed in toolpath? Does that even latch? Nope, it's way too big. I could try and fix that by cranking up the welder. Now this is the big chunky foot switch which came with my welder, and unfortunately I don't really have a good place to store it, so I tend to just leave it sitting up here on top of the welding cart, and it's fallen down a couple of times and now it's stopped working. Probably just a damaged potentiometer, but I was chatting to Arc Captain about it and they suggested they've got a new design, and so they sent me one. This is much more compact, still nice and rugged, a good solid unit, but no longer has quite the mass of the old one. So that's brilliant. Thanks a lot, Arc Captain. Now there's a strong chance that this is all just going to be a big failure, because I suspect that this is a tool steel, like 4130, 4340, something like that, just from the way it cuts and that. So when I put welds on it, it may just make a big mess and make hard, brittle welds that I can't machine. But at the moment, it's scrap. So what have I got to lose? Right, assuming this is a tool steel, let me just put a bit of heat into it before I start welding. We've put way too much heat into it now. I really need to learn to feed the wire better. Is this foot pedal actually working? It also feels like I've got full power, but as soon as I back off, nothing happens until I go into the off transition. Okay, so the foot pedal system's obviously not working because I've only got full power or ramped down to shutdown. I'll have to contact our captain and ask what the story is there, because I think the setting's right. I'm on 2-touch, DC TIG. I thought you set your maximum power and then just control whatever power you want off your foot switch, but that's not working. I'll just turn down the current a bit, and I just want to build up around the lip, really. Whoops, that's got tungsten in it. Now, although this all may be completely pointless, I do like playing with a welder. Well, it's now cooled down. It cuts with a file, so let's have a go with the milling machine. Well, that weld knocked down without too much problem. Just missed a bit of weld right there, but otherwise the whole edge is complete. That might clean up with the dovetail cutter. Let's have a look. So is that worth doing? Well, I would say yes. It doesn't look that pretty. There's a few little spots where I made hollows with the welder. Now it mounts. It's nice tight fit. So that was a good save. One extra tool holder. I've now finished all of the dovetails on the basic straight cutting tool holders, but I've still got 2 more to do. These are going to be facing tool holders. So with this, you'll be able to clamp a tool across the front and not just along the side of the tool changer. And these are the tool holders that I'm most looking forward to, because I haven't had a facing tool holder for this lathe. Oh, look, we've been visited by our #1 fan,
Hi there.
Nico.
Hi there.
So,
Quite a long time no see.
Happy New Year.
Happy New Year to all of you.
What's your New Year's resolution?
2026, definitely bring more project here.
Wow, bad.
That was a good plan on my side.
My New Year's resolution is to finally throw out my workshop shoes, which I've been using for 5 years and I've got holes in them.
Not what you call some safety shoes. I know them. And what are the plans for you, 2026?
Mill some stuff. Make
2 new
things.
machines.
No new machines in 2026. That's also one of the plans.
No new machine.
Yeah, no new machines
No new
in
machine.
2026. No.
Is there any limitation, any small written test?
Nope.
Like
Nope.
size, function, replacements?
No. I've got all the machines I need for
So
2026.
replacement does not count as a new machine.
No.
It's not a total count. Doesn't have to increase. Like if you manage to sell like the old small lathe,
Oh, now you're getting. Oh.
that's still -1. Will you make +1 or would we start 0?
We'll probably. I don't know. We'll be flexible.
So are you unsubscribing Willhaben, eBay Kleinanzeigen, all the machinists sources?
No looking in any classified ads.
Okay, does a present qualify as a new machine?
No, that's different. That's a present.
So you
It's very different.
It does not qualify
That's
as
totally
a machine.
different.
Okay,
Yeah.
okay.
Completely different.
Is it on tape?
Yes.
Okay, that's gonna be published. This part will be published.
Well, thanks for coming over. So to rough out this sort of L shape, I wrote a quick tool path, just using a couple of variables and then a couple of subroutines. First to bench across the bottom, then to go down the side. I was having some issues with that not working. Turned out you can use parameter numbers from #1 through to #5000 something in Linux CNC. And I'd used #1, 2, 3, 4, 11, 12, 13, 14. But the first 30 are, I guess they'd be static variables. So I had to redo this with 31 onwards and then it worked. Nice. On that first one, I was a bit concerned about tools rubbing along this edge, so I gave it about an extra millimeter of clearance here. I'll take that away on the next one. It's too tight. It's also got a reasonably rough surface finish. Let's take a look at those inserts. And you can see they're taking a bit of damage. Yeah, all of them have got a bit of chip out. So I'll switch those out for new inserts and just recut that last pass. Yeah, that now fits nicely, so that finishes up all 12 dovetails. Next step's going to be drilling holes. But before I do that, that dovetail cutter made a sort of an irregular beating sound. So I suspect that when I made this, I didn't get all of the insert pockets at exactly the same depth. Let's take a look. So if we zero on that one, yeah, that one's 4/100ths under. And that's 5 or 6/100ths under. That kind of explains why it sounds like a fly cutter, because on the very fine cleanup pass, this one's probably doing all the work. There was also a comment that said I may have an issue with a lack of back clearance, but that's not the case. There's definitely clearance on all 3 flutes behind the inserts. Just didn't quite get the pockets perfectly even. All in all, I'm pretty happy with this dovetail cutter which I made. It's definitely a vast improvement over the triangle insert one I had before. These inserts still didn't hold up terribly well, but that might also be because they're cheap inserts, and that is pretty tough steel. Thanks a lot for watching, and if you enjoyed this video, stick around, because the next one that shows up is going to be just right for you.